Hi, this is Hunter LaFleur. I'm doing a video cast on program run by Matlab, and what I'm going to be doing today is working on projectiles. This is going to be used for my physics as a numerical calculation problem using computers. First, I set up my screen. You see it CLC, clear, close all, format, compact. Those things basically clear workspaces and other elements of the program while it's running, and close any open arrays or matrices or vectors, and also any graphs. Then I'm going to go ahead and set my variables. I got G is equal to negative 9.8. I also have G is for gravity. I have N is equal to 50. That's the number of times I'm going to use it. It's a variable used on it, and that'll give me 50 different spacings. And I can plug that in wherever I want a number specifically. I also have V for my initial velocity. As you might see right there, I have input. It allows me to input a velocity manually, and I have a string that gives the user a command for them to do the input. Also, I have the same thing on angle. I have an input, and then you can enter your degrees. Then I went ahead and set a variable for velocity in the x direction. Initial is equal to velocity times cosine in degrees times the angle. Then I use of the angle that the user inputs, and I have the velocity of y initial. It's v times sine degrees, and you plug in an angle. The parentheses around angle state that it's looking for an input for that. They call that a function. Okay. Then we go ahead and set up our time, which is -2 times velocity of y initial over gravity. Now you might see I have a big T right there. That's going to be the main time I use. So little t is going to give me the total time that it takes from the projectile to get from one end to the other. The big T is going to give me a series of small incremental times, and we use a function called linspace on this program Matlab that determines a certain number of units. So let me explain. It starts at 0 in the parentheses, and it goes to the number t, which is the ending number. The number n gives me the number of divisions in between that. I set n to 50. So it's going to go from time initial to time final, and it's going to give me 50 increments in between there. Now I have x is my position. Is set equal to velocity in the x direction initial times the time. Also going to have y in the y direction, which is the y position, which is velocity of y initial, which we had set up earlier, just like v of x of I, times the time, plus 0.5 times g, which is -9.8, times t, and that's going to be up to the power of 2. Now I'm going to set up a function called distance, and I'm going to use that for my printing basically, or my graphing. Now my graphing is going to have a bunch of functions involved in it. So for every time that I run the program, which will be 50 increments, 50 times, it'll give a calculation. It'll give a new calculation for big T, a big calculation for X, and a big calculation for Y. The semicolons in between drop it down one line. So T is on one row, X is on another row, and Y is on the third row. fprintf is the print function. Now, as you can see, I have fprintf and then a whole bunch of words written into it. That's called a string. That string gives me a certain amount of stuff right here. Now, if you look right here, I have 5.2f. That's going to be a total of 5 units, and 0.2 of those units are going to be decimals. F stands for a float, which an integer is a whole number. A float is a number that has a little less. It can do decimals. So it gives me all the parameters. I put those in where I want to have inputs put in. And at the end, I put in my distance right here, my word distance. And every time it runs, it's going to call distance, which is these variables, and plug them in to this part, and this part. Then I went ahead and I'm going to plot the whole program out as it runs on XY. And we'll set the axes to an equal position. We'll go ahead and run this program right now. And my inputs are going to go ahead, let me minimize this a little bit, restore it back to its spot. Now it's going to ask me, please input initial velocity. I'm going to put 50, and that stands for 50 meters per second. I have the units right there, 50. It's going to ask me for my degrees. I'm going to go ahead and put in a big heavy duty degree, say 80. And it's going to be a steep climb. As you see, my graph popped up, and it's going to go ahead and give me the projectile's movement through the course of time. And I'm going to have multiple little values of time right here. This is my time on the bottom. This is my distance on top, on the y-axis, my time on the x-axis. And if you look down here at this part, my printout from the fprintout is also going to give me specific values for each of those times. Well, that's Hunter's screencast or video for numerical calculations using computers or computer software. And the program I've been using is Matlab. Thank you.